Is this as crazy loud as it is for me? Okay. Hi. So my name is John Paul. I'm going to talk to you about the real bad parts of JavaScript. Thank you so much for coming and listening. You can find my slides up there at that URL. There is some code for some of these slides, so it might be useful. And also, there's my Twitter handle. I'll talk to you a little bit about myself now. So my name is John Paul. I work for Conde Nast, a magazine publisher in New York City. And I love JavaScript. JavaScript is the language that I love writing, although I have my dalliances with Scala and indiscretions with Clojure now and again. I love JavaScript, and I keep coming back to it. My Twitter handle is John K. Paul. I'm on Freenode all the time. Feel free to ask me questions on IRC or on Twitter whenever you'd like. So I want to get a rough idea about how many developers I have out here. So who are developers? Can you raise your hand if you're a developer? Great, OK. And how many of you write JavaScript? OK, how many of you actually want to write JavaScript? OK, good. That's actually much better than I was expecting. I was going to try to get you really excited. But if you're already excited about it, I don't know how much work I'm going to have to do. But I'll get further into this in a second. So the people who do not write a lot of JavaScript, can you raise your hand for Java? Ruby? Python? OK. So Ruby and Python. So a lot of my background has been spent training Java, Ruby, and Python developers in JavaScript. I was a consultant for a while when I would go in and explain some of these difficult issues about the core semantics of the JavaScript programming language. And that's roughly what I'm going to be talking to you about in a second. So is this really scalability? So I'm going to talk about scalability of your JavaScript knowledge so that you can learn a lot more. Also, performance, because performance doesn't actually fit on this slide at 1024 by 768. I'm going to talk to you about how to really work on the performance of your front-end team. Who works on a team of JavaScript developers? Raise your hand. OK, great. That's gratefully becoming a little more common, but for the majority of my career, I've been working on teams with one JavaScript person, one front-end person, and everything else being on the server side. So my talk is called JavaScript, the bad parts, the real bad parts. I'm going to compare this to the JavaScript, the good parts. There's a book by Douglas Crockford called JavaScript, the Good Parts. Who's read it? I'm a big hand-raising guy. OK. So JavaScript, the good parts, it's a very small book. He doesn't actually think that there are that many good parts in the language. But in the end, there is a small appendix. And that small appendix is called JavaScript, the bad parts. And the bad parts that Douglas Crockford lists are these particular features of the language, with, eval, type coercion. But I'd like to argue that realistically, as a JavaScript developer, these issues don't come up very often. Very rarely do I come across with in some code, or even eval. And type coercion, while sometimes causes an issue with my own code, really it takes only a few minutes to understand. I will come across the issue and say, oh, my conditional is converting one type into a string when I'm not expecting that, and then I understand it. These particular issues that Douglas Crockford brings up is not something that takes hours, days, or months to really understand. So what I want to talk to you about are the real bad parts of the language, the parts that once you do grok completely, you will grow leaps and bounds with your ability in JavaScript. These are difficult concepts to understand that I like to say that it takes a really high blog post to understanding ratio. So you have to read dozens of blog posts, and I'm sure some of you have, to begin to understand some of these issues. You want to bang your head against the wall every few minutes sometimes with JavaScript, and I'm going to try to remove some of those feelings. So although a lot of you already like JavaScript, so I'm not too worried, but often it's a problem to get people excited about it. So the first thing I have, so how many of you have had problems with this keyword in JavaScript? Raise your hand. OK, so I'm going to explain that pretty thoroughly here. So there are 5 distinct ways in JavaScript to set this. This is in large contrast to Ruby and Java and Python. Python passes the self argument that it's all very static. It's not as dynamic as it is in JavaScript, and therefore it is not as confusing when you first come to it. The 5 different ways are the method call, the baseless function call, then you can use call and apply, and there's also, you can use the new keyword with a constructor. These are 5 distinct ways to set this. So the first way is a method call, and I put this in air quotes because JavaScript doesn't actually have the classically object-oriented idea of a method call or even an instance. What this is if I can show you in this code, I have an object with 2 properties. One property is a string called first name, full name. The second property is a function, and in that function, it uses this keyword. Now, when I run this, the function actually alerts, hey, my name, John K. Paul, and this is because this inside of the function on line number 4 is set to be whatever is to the left-hand side of the dot in the function call itself. So on line number 8, the object is obj dot. Because obj is on the left of the dot, then this inside of that function is set to obj itself. This one is fairly straightforward and not that complicated. It'll get crazier. So the next one is the baseless function call. This, again, does not have any exact name in the specification, but roughly it is when you pluck a property out of an object that is a function, you set it to a variable in your current scope, and then you call that with no dot. This is, again, something we would use sometimes, but in this case, there is nothing to the left of the dot. And when I run this, I get, hey, undefined. This is because this inside of my, this is inside of the function alert name is taken to be the global object if there's nothing to the left-hand side of the dot. This is something that is actually changed in newer versions of JavaScript. So if there's in the version of JavaScript called ES5, the 5th version of ECMAScript, there is a new directive called useStrict. And when you type useStrict to the beginning of any one of your functions, what happens is it runs in a much stricter mode of execution. So in this case, when I run it, I don't actually get anything, but I do see an error inside of my console that says, cannot read property full name of undefined. This is because instead of the default behavior, which is assigning this to the global in the browser that happens to be window, this useStrict directive is making sure that whenever it would have defaulted to the global context, it actually sets it to undefined explicitly. So on line number 4, it looks up the full name property on undefined, which is a runtime error. So does anyone have any questions? Because I want to make sure that I answer as many questions as possible. If you do, raise your hand, and I will definitely get to you. So the next one is using call. Call is a function that is itself defined on all functions. In JavaScript, functions are just objects like anything else. They can have properties attached to them. They have properties attached to them by the runtime itself. And call is a function that is defined on functions that, when called, allows you to pass an explicit context that you want this to be inside of that execution of the function. So in this case, I am taking out alert name similarly to how I did in the previous example with the baseless function call. But this time, I am executing that function by calling the call function. This is probably difficult to say. Calling the call function with the first parameter as the context that I want this to be inside of that execution, that particular execution. So here, because I'm passing a new context which has the full name of John Doe, when I alert this, I get, hey, John Doe inside of my alert box. This has changed my text for some reason. This is because, let me refresh this and get back here. So this is because on line number 4, inside of the function alert name, I'm looking up on this to get the full name property. And I'm passing on line 13 the explicit context for this. The rest of the parameters to the call function are passed as parameters to that particular execution of the function. The next example is almost exactly the same. Call and apply are two sides to the same coin. Call allows you to pass parameters to the function as parameters to call itself, whereas apply takes a new context as the first parameter, and then as a second parameter allows you to pass an array. So this is very useful when you want to pass the arguments of one function into another one. Here, again, I get, hey, John Doe, exactly the same as I did before. What questions do you have? OK. So the last example here is using a constructor with the new keyword. With the new keyword, what happens is this inside of the function is set to a completely new object that is generated by the runtime itself. So on line number 8 here, when new foo is executed, the foo function is called, and this is set to a completely new object. And that new object is, by the runtime, returned at the end of that function, even though you don't return it. So in this case, I also just get hey, because say hey is a function defined on the object that will eventually be returned from that new expression. So in the next version of JavaScript, there are other ways to set this. I'm not going to go into that right now, but we are on the edge, as a JavaScript community, we are on the edge of a new version called Harmony, or ECMAScript 6, that makes some of this even more complicated. But I won't get into that now, but if you have any questions, please feel free to ask me now or afterward. So the next thing I'd like to go into for your JavaScript scalability is what on earth is prototypal inheritance? So people from different programming language backgrounds, especially those that come from programming languages that have a more classically object-oriented system, they look at prototypal inheritance and are extremely confused as to why this exists and how you're supposed to use this to actually achieve your goals when you're writing code. Like Boromir says, one does not simply just learn prototypes. There is no one blog post you can read or no one piece of documentation on MDN that suddenly makes this make sense. So this is an example. I don't know, have any of you seen pictures like this? If you actually try to look into prototypal inheritance, there will be diagrams that have the word prototype everywhere and lots of arrows and showing that, trying to show you how prototypal inheritance works in JavaScript. This is the canonical cat is an animal example from the usual Java example for how classes work and how instances work. I've looked at this for hours, and I still don't think that I really understand what this is trying to say. So don't worry if the same thing happened to you. What I want to talk about is, what is inheritance really? And inheritance, is it classes? Is it blueprints? Is it super? It's really none of these things. Inheritance is all about code reuse. This is what we really care about as developers. We care that we can write code once, use it in multiple situations, write code once, and be able to change it in one place without having to go through your code base and understand where similar functionality lives. So prototypal inheritance makes this very easy, but not in a way that we normally expect to deal with it when coming from Ruby, Python, Java. There are many other programming languages. These are just the ones that I happen to be mentioning right now. So I don't want you to think about new. I don't want you to think about super or extends. I don't even want you to think about JavaScript's own prototype property. I know that's confusing. Prototypal inheritance is all about fallbacks. And this is the way that I think it is most easily explained and most easily understood. So this is the slide with the most code. So definitely, if you don't get this right here, they will be in the slides afterward. But bear with me. This should be pretty straightforward. So how does prototypal inheritance actually work? In the first few lines of this code, I set up some object called base. Base is what I call the fallback. This is the the object that should be looked up for properties when the property doesn't exist on a new object. Where the magic happens of JavaScript is line number 10. I'm going to create a new object that shares the functionality defined in base using object.create. Object.create is a function that is given to you built into JavaScript that allows you to create these chains of fallbacks, that allows you to share code most effectively, rather than understand all that has to deal with the prototype property in JavaScript. Object.create should be your go-to, where you can find and understand how to share functionality and implementation between different pieces of code. On line number 10, I create a new object from base, and I define some new functions on that. Now, when I call this function, alert name, I actually do see my name here, but get full name on line number 12 is not actually defined on object itself. It's defined on the base. Now, this is the fallback relationship I'm talking about. When a property is looked up on obj, it goes, if it's not there, it will go to base and look at that property up there. Now, this is code reuse exactly. The property get full name does exist in object, and the two functions triple equal each other. They are the exact same location in memory. This is what our goal is. This is what we want to do. We want to write code once, use it in multiple places. This allows you a very straightforward way of doing that just doesn't happen to fit with the usual canonical classical explanation of how classes work. There isn't actually a blueprint here and an instance of that blueprint, but rather there is sharing of code using this fallback relationship. So there's a caveat here. So not all JavaScript environments have object.create, most notably old Internet Explorers, which we are all annoyed about, at least people working in the browser-side JavaScript. But we do have a solution, and that is this particular piece of code that is very close to create, that is as close as we can get in old IEs. It does everything we need it to except the other parameters to object create that don't necessarily need to be used to achieve the goals I'm talking about. If you have questions about how this works, please ask me afterwards. I'm not going to explain it here because it's a little more in depth, but this is a short little shim that you can use to achieve functionality just like I described before, where you can have one object, when a property is looked up on that object, it will look up on something else if it doesn't exist. So in JavaScript, the prototype property is doublespeak. That's why graphs like this are really confusing, because this particular diagram has the word prototype in it about 5 or 6 times, and it actually means different things in different contexts, which is why I would encourage you to think about it a little differently. The first prototype is a property on a function. So the property on a function is prototype, and it is defined on all functions in the JavaScript language. It's part of JavaScript itself. So what this is I would like to be better called fallback of objects created with new. If this was the name, it would be a lot more straightforward to understand. But that didn't happen to be the way that ECMAScript committee made this work. So the next prototype is an internal reference of every property. Both of these are represented on this diagram, but they are not sufficiently distinguished so that it makes it a little confusing. The second prototype in the new version of JavaScript, ES6, has renamed this to call it DunderProto. So this is a new name. Hopefully once this has saturated the market, which will take a while for old browsers to go away, and when blog posts are written and updated, we will have a lot less confusion trying to understand JavaScript, because one of these particular naming clashes will have gone away. This is coming in the future. It's not necessarily there now. Some new browsers have implemented this, as well as Node in a particular flag. So the last few things I want to talk about that is very difficult to understand in JavaScript without a lot of thinking and blog post reading is scope. So scope in other programming languages is pretty straightforward. Let's take a look at this example. In this example, I have an array. I am iterating through that array, and pushing functions into another array that I will then execute. Looking at this code, it looks like I'm iterating through the list of numbers, 1, 2, and 3, and I should be alerting 1, 2, and 3 after this. So it looks like it's really straightforward. It's only 8 lines of code with a new line. But when I run this, I am totally surprised because it says 3, 3, and 3. This code looks like it's really obvious and straightforward to understand, but it actually does something that is completely surprising. And this is a problem with, or this is an issue with how JavaScript does not have something that many other programming languages do. JavaScript does not have block scope. So this variable that's defined on line 4 is actually, there's only one memory reference of item, and that just keeps getting reset. The block for the for loop doesn't actually create a new variable. So only functions in JavaScript can create scope. And this is something that is a mental hoop to jump through when you first start reading, as well as writing and getting better at your JavaScript code. As you move from beginner to intermediate to advanced, this is something you encounter much more frequently. Because only functions can create scope in JavaScript, this is a pretty common pattern, even though it's kind of ugly. All it does is inside of the function, inside of the for loop itself, create a new function that you immediately call with the value of I for that iteration of the loop. This works as expected, and it will alert 1, 2, and 3. But here you have to create your new function every single time, and it looks pretty ugly. CoffeeScript has the do keyword to get out of this particular mess, that if you do happen to go into CoffeeScript, and that's how they solve this problem. And the next version of JavaScript, ES6, adds the let keyword. The let keyword is very similar to the var keyword, except it is actually block scoped. This will allow us to write the code like how we wanted to write it before, without worrying about the surprises that JavaScript itself gives us. So what questions do you have? Anything? Okay. Okay, so the last thing that I want to talk about is function hoisting. So JavaScript has another confusing behavior that I find to be pretty bad about it, but once you understand, does actually make sense. Here are 3 pieces of code that look very, very similar. There are a few parentheses and a few brackets that are different, but they look like they should be doing exactly the same thing. But when I look in my console, let me actually run these. So the first one gives me an error that says undefined is not a function. The second one gives me a completely different error. It says test func is not defined. But it is, it's right there. I don't really see the difference. And then the last one seems to work. The last one works as expected. I get hey, and it's pretty straightforward. So what is the difference here? Looking at this, it doesn't seem like there's much difference. So the difference here is something called hoisting. In JavaScript, JavaScript acts as if it reorders your source when it actually executes. Variable declarations and function declarations are moved to the top of the scope that they are defined in. So it looks like if you type the source in the top, JavaScript seems as if it interprets the source at the bottom. It moves all variables to the top, and it moves all variable declarations to the top on line number 2 of the second example, and it moves the function declarations all the way to the top of the current scope. So this makes, once you understand this, it's pretty straightforward, but I glossed over the fact that a function declaration and a variable declaration, you have to know what that is in order to see it being moved. In this case, the reason that the last one worked is the second line in the last example is actually a function declaration, whereas the second line in the second example is a function expression, but they look exactly the same. The only difference is the parentheses around the outside. So how do we tell the difference between a function declaration and a function expression? This is actually pretty annoying, but there are rules. So the only easy rule is that if there is no name, it is definitely a function expression. If there is not a name, if there is a name, then it depends on the context. Here are some examples of what are hoisted and what are not hoisted. In line number 7, the reason this is an expression is because that particular function is in an assignment expression, and because of the way JavaScript works, if you have something in an assignment expression, it is an expression. Similarly, if on line 14, because it is part of a new expression, therefore JavaScript interprets it as an expression. And a declaration is what you see on the first line. So once you do understand these rules, which I would love to answer questions about afterward, a lot of this becomes significantly easier. So what I want you to take away from this is that this can be set 5 different ways, and it's not, once you understand those rules, it's not that difficult. The next is prototypal inheritance is about fallbacks, and fallbacks is the way to think about how inheritance should work in JavaScript in contrast to the other programming languages that you might have been used to. Only a function can define new scope until let. Hoisting acts as if source code moves around. It doesn't actually move around, but once you understand the rules about function expressions and function declarations, how that happens mechanically will be in your head, and it'll be a lot more straightforward to understand what your code is doing and why it is behaving the way that it does. And then the last one, for browser people, ES6, the next version of JavaScript, depending on who you ask, this is a link to a blog post by Paul Irish, in approximately 8 years will make a lot of our lives easier because of the updates that are coming to the difficult parts of JavaScript to understand. But again, we have to see how that happens. If you happen to be Node developers, a lot of what I'm talking about you can use right now. Node itself has a flag for Harmony, which is the name for the newer version of JavaScript along with ES6. Once you turn on this flag, a lot of the new fancy features here that will make things less confusing in the future can be used right now. And the last bad thing is semicolons, so don't use them. They're horrible. I'm serious? I'm not? Okay. So thank you so much for listening. Thank you to ProIdea. I'm very happy to be a part of this conference. Do you have any questions? I would love to hear them. Yes.
Thank you for the talk. It was great. What do you think about CoffeeScript and other sub-languages that somehow solve the problems you mentioned?
Sure. So my opinion, so CoffeeScript has syntactic conveniences that I'm very much a fan of. Some of those syntactic conveniences, sorry, I feel like I'm being loud. Some of those syntactic conveniences have actually been included into the newer version of JavaScript. CoffeeScript itself has the difficulty with purely transpiled code bases are that they can no longer track newer features that are added into JavaScript without potentially some difficulties. For example, so JavaScript has let. The way that do is implemented, that's difficult to transform into. Similarly, the new version of JavaScript has generators. CoffeeScript has issues with that. So the difficulty that I have in switching a code base entirely to CoffeeScript is that it's difficult to add in the newer features as they do become available. Personally, I'm more a fan of transpiling ES6, the new version itself. There are mechanisms to do that. There was actually recently a blog post by Adi Osmani that talks about how to write ES6, Harmony itself, and have a transpiler compile that to ES5, and then have shims to go all the way back to ES3 if you really need older browser support. But CoffeeScript itself, I've enjoyed writing in. There are reasons why I would not necessarily choose it for a production deployment. Any other questions about JavaScript in general, not necessarily what I've been talking about? Okay, great. Thank you so much.
Thank you, John.